Well, now I'm very pleased to introduce Martin Fowler. Martin is an author, speaker, and in his words, a loudmouth pundit on the topic of software development. He's worked in the industry since the mid-'80s, starting in what was then the brand new world of object-oriented software. Spent much of the 90s as a consultant and trainer, joined ThoughtWorks in 2000. He's the author of 6 books. The first one, the way that I discovered Martin was his book UML Distilled, because I was one of those UML guys a long time ago, and trying to puzzle through giant documents, trying to figure out what UML was all about. And then he has this wonderful little book. It's, what, half an inch thick, and it's just a marvelous book that takes you right to the east. So that was the first book that I read of Martin's. He's also written Patterns of Enterprise Application Architecture, a marvelous book on refactoring called subtitled Improving the Design of Existing Code, a book on analysis patterns of, that we see over and over again as we do analysis. His latest one, called Domain-Specific Languages, is fantastic also. I've been after Martin for a number of years to come and present. I'm so thrilled that he's here. Let's hear it from Martin Fowler.
Thanks. Yeah, of course, if you're quieter than the applause you gave to the previous speaker, I'm going to feel all depressed and unwanted. Okay, so I'm going to do what I have been doing for a year or two now with my keynotes, which is, instead of, obviously the title, in case you haven't noticed, is one of those anonymous titles that allows me to talk about whatever I want to talk about. It's what Lee refers to as an IOU title, meaning I'm not going to tell you what I'm going to talk about. I'll make it up sometime before I actually go on stage. And in fact, what I've been doing with the keynotes is I've decided that rather than do one long, boring keynote, I'm going to give you 3 short, boring keynotes instead. The first one, I'm going to look at a common problem in testing, why it's important and why we should fix it. In the second one, I'm going to look at why software design is something that's important and worthwhile to us and why we should care about it. And then in the third one, I'm going to muse a bit on the fact that it's been 10 years since the Agile Manifesto and where the Agile movement has been going and where I think it might go next. So I will kick off by talking about non-determinism and testing. This is, if you read my website and stuff regularly, this is an article I posted a month or so ago. In fact, everything I'm talking about is stuff that's posted on my website, so if you read stuff on my website, you might as well head out and enjoy the glorious architecture of downtown Las Vegas. So what do I mean by non-determinism and testing? Well, let's imagine I want to run a test, and it goes red on me. And I go, oh, okay, what's going on here? Let's run that test suite again. So I run it again, and oh, now this time it's green. Okay, let's run it again. Maybe things are okay after all. Well, let's just be absolutely sure and just run it one more time. Oh, now it's gone red again. What the hell's going on here? Has anyone had this kind of reaction to tests? They seem to work and not work almost at random times. Okay? Yes, that's what I call something that's non-deterministic. By the way, anyone recognize this GUI window? Anybody remember this GUI window? Anyone actually used it in their young youth? This is version 1.0 of JUnit. I had to dig out that from some old CDs to find it. But I thought, you know, if I'm going to show anything else as a test window, it really has to be the original JUnit. Anyway, people talk about these test failures. They might talk about them as intermittent failures. You hear the term flaky a great deal. You know, those tests are flaky. But the term I like to use is non-deterministic. And it's non-deterministic because it seems to pass or fail in ways that are seemingly random to me. Now, there's another term for non-deterministic, when it comes to testing. And that is that non-deterministic tests are a complete waste of space. They are useless. And they are useless because the whole point of tests, with a regression suite like this, is that what you're doing is you're using it essentially as a bug detection mechanism. Did I screw up somewhere when I was doing something over here in the code and broke an assumption over there in the code? And its value is at the fact that they tell you right away. They go red and they say, whoops, you screwed up. And if you're like me, you say, yet again, but thank you very much, tests, because since I screwed up quickly, I can quickly fix the problem. The beauty of using this kind of automated testing suite is the time between making the mistake and realizing you've made a mistake is very short. And because it's short, you haven't done that much, and therefore you can figure out what you did wrong and you can fix it. But the problem with a non-deterministic test is when it goes red, you just don't know what to think of it, because then you'll run it again and it'll go green, and it'll go red and it'll go green. It's not giving you reliable information. So it's effectively a waste of time. You might as well just ditch it for all the good it's doing you. But actually, non-deterministic tests are actually worse than useless. They're actually a very nasty thing. And let me explain a little bit why they're worse than useless. Let's imagine I've got a suite of tests, whole bunch of tests, and they're all okay. If I run that suite, I don't look at all the individual tests, I look at the overall result of the tests and say, okay, the thing is green. If I have a suite of tests with one failing test in it, and I run it, my first reaction is, oh, the whole suite is red. I then dig into it to find out, okay, which failed test caused the suite to go red. But if I have a test that is got a non-deterministic test in it, what happens to the overall suite? Well, it's sometimes green, sometimes red, sometimes green, sometimes red. The whole suite is affected by that test. It's what's happened is the non-deterministic test is kind of like some kind of infection that goes and infects the entire suite and causes no end of trouble. And that's why non-deterministic tests are such a dangerous thing. So what do we do about them? Well, it is certainly important to realize that we care a great deal about this. If you allow some non-deterministic tests into your test suites, essentially what's going to happen is early on people will say, oh, okay, the test suite failed, but it was that test and we know it's flaky. And then, but after a while, people say, oh, that test suite, it's flaky. And it basically makes every test useless. And people stop trusting the tests. And when tests fail because you screw up, you don't notice because it goes red and, oh, those tests are flaky anyway. And at that point, all of your tests, the good ones and the bad ones, become useless. And that's why non-deterministic tests are a virulent infection and why you have to do something about them. Because if you don't do something about them, your entire regression suite will become useless and you'll lose all the benefits of automated testing. And I've seen this happen. I've talked to teams where they've said, oh yeah, our tests are useless and we don't really trust them very much. We might look at them occasionally, but we don't do anything seriously as a result of them. So we absolutely must take action quickly when it comes to dealing with non-deterministic tests. So what do we do about them? Well, the first step is relatively simple. What would you do if I were to told you that my great friend Linda here has a virulent infection of smallpox and bubonic plague? What would be a reaction? Run away? Get her out of the room? That's the thing, right? What happens when somebody is infectious? You want to put them into quarantine. And that's the first step for dealing with a non-deterministic test. Set up a quarantine area, move that test to quarantine. Now, the quarantine tests aren't dead. You haven't got rid of them. You know, we wouldn't kill Linda just because she had bubonic plague and smallpox. We would want to cure her, of course. But the first step is to get the test away from everything else. That way, the rest of the test suite can carry on okay. We'll continue to trust it, and we've at least pulled the test out of the main line. If you're using a deployment pipeline, then you take the quarantine tests out and you don't make them part of your regular pipeline. That way, the regular pipeline keeps thundering along, is able to give you useful information, and you're not infecting the rest of your test suite. But when you do use quarantine, you've got to be careful. You've got to be careful to limit that quarantine, because the danger is that if more and more tests become non-deterministic, you'll sling them all over to quarantine. And of course, any of those tests in quarantine aren't actually doing any good. They're not infecting the rest of your tests anymore, but they're still useless. And that means you've not got important pieces of test coverage for your application. So it's important with quarantines to set some kind of limit. So limits I've come across is saying like no more than 3 tests are allowed in quarantine at once. If it goes above 3, then we have to take action and to do it, or it might be that no test is allowed to stay in quarantine for more than a week or something like that. Set up some kind of limit that limits how much stuff is going to be in quarantine. Because what we have to do is we have to figure out, okay, how do we deal with the non-determinism? And that means understanding the causes of non-deterministic tests. Now, I'm not going to have time to go through all of the causes in detail in the talk, but I'm going to pick up the highlighted ones. You can go through to the article on my website to get more on the details. But I will go through a few of these common causes. And I'll begin with the first one, which is probably one of the most pernicious ones. So say we have a test. We've got some orders that are coming in out of the outside world, and we want to make sure that we can sum the value of these orders up. So we have some test that says, given 3 orders in my test fixture, the sum of the orders equals the value that I know it should be. Simple kind of test. And somewhere else I have another test. And in this test, I test that I can load a new order into the system, and then once I've got that new order, it's there, it's part of my test fixture. Now, great tests, work really nicely. But what happens if instead I do the load new order test first, and then I do my sum of tests? What happens, of course, is that sum of orders is going to go red. And what's happened here is a lack of isolation. The 2 tests aren't isolated from each other, and as a result, depending on which order you run them in, one will succeed or one will fail. And this is a common problem with non-determinism, because you'll find that depending on the way the tests run back and forth, they don't necessarily pass or fail. Particularly nasty consequence of lack of isolation is, of course, when the test suite fails, and you see, oh, it was this test that fails, usually one of the first things you do is you run that test on its own to see what's going on. But if you've got an isolation problem, you run it on its own, it'll typically pass. It's only when it's in the suite that it fails. And typically depending, as I said, on where in the suite it runs in its order. So isolation is something you need to deal with, and there are 2 broad strategies to dealing with this problem. The first approach is to track dependencies. And that is to know that, oh, I have to run my check of the sum test before my check of the add the new test. The other approach is to isolate. And to isolate means to write all of your tests in such a way that they never stamp on each other, but they don't interfere with each other in any way. And when it comes to looking at these pair, I have a very strong preference. I don't like to track dependencies. And the reason I don't like to track dependencies is because it's complicated. You're always in this position saying, oh, this test has to run after that test, but before this test, and it's a pain in the neck to keep track of. It also makes it difficult to run individual tests individually. And furthermore, as you get a larger and larger test suite, and you start thinking, oh, maybe we should kind of spin up some cloud instances and run this stuff in parallel, dependencies will get in the way, because you have to be aware of the dependencies to decide what order to run your tests. Of course, I have to mention that kind of obvious to me here that anything complicated to keep track of, it's a perfect opportunity for a tool. So I'm sure there are tools vendors who are out there who are saying, oh, you've got to track your dependencies, and for that you need a tool, and hey, we happen to have one. But on the whole, I don't like tracking test dependencies. What I prefer is isolation. And there's two basic strategies to keeping things isolated. The first approach is a cleanup strategy. And that basically says every test has to ensure that it leaves the world the same way that it found it. So in the case of loading the new order here, one of its roles is that it's responsible for deleting anything new that it creates as part of it. And this is why you find in a lot of testing frameworks there is usually a teardown part to the testing framework that allows you to get rid of any resources that you may have created that you need to explicitly destroy at the end of a test. And this is a pretty good strategy, but it does have one noticeable disadvantage, and that is that if you make a mistake, it's hard to deal with afterwards. Because the error is the test over here that didn't do its teardown properly, but you don't see a problem until some other test that depends on having a clean slate fails. And there's a big distance between the fault and the failure, the cause of the problem and what you can see of the problem. And as a result, cleanup is it's an okay approach, but it's not preferred, because it means you've got to do a good bit of debugging should you get into an isolation problem. The other approach is to use a blank slate. And basically the idea with a blank slate is that every test creates what it needs for itself automatically at the beginning of the running of a test. And certainly a lot of unit test frameworks encourage this kind of behavior. Nice thing about the blank slate is that way each test really is independently responsible for its own behavior. And as a result, that limits the amount of isolation problems that you might run into. The disadvantage of using a blank slate is that sometimes building up that initial fixture can be expensive. So, for instance, this is particularly the case in larger scoped functional tests that often rely on, for instance, a database being set up. And loading up a database worth of stuff for every single test, that can take time. And there are tricks you can use to get around it, like copying database files rather than doing inserts and that kind of thing. But that is a factor. So sometimes you have to balance the cleanup and the blank slate approach. A common trick that people use for cleanup, for instance, is that when you're running database-oriented tests, to run them inside a transaction and not to commit the transaction, to roll it back at the end of a test. And that's a good way, for instance, of helping to do that, providing, of course, the thing you're testing isn't dependent upon transactions being committed. But broadly, those are the two strategies you need to follow. And on the whole, I prefer the blank slate one, unless other constraints push me towards a cleanup approach. But that's about dealing with isolation. It's hard to say what proportion of causes affect flaky tests, but isolation is certainly a real common case. And it's also one of the more messy cases to deal with, because particularly if you've got that failure of cleanup, it often requires a bit of detective work to do that. But that's what you need in order to keep a healthy test. So that's our first cause. Now let's move on to our second cause. Our good friend, asynchrony. So asynchrony is very useful to us in many ways. It allows us to build systems that are responsive even though they're carrying out long-running operations. But it does, of course, lead to testing difficulties. And the basic problem is we invoke some function on typically some remote service, but it could be something more localized. We have to then wait in order to see if we can get some kind of answer. And the common approach that typically people do when they do this, is to do this. You've got something along these lines. That is to do what I refer to as a bare sleep. How many people have done this in their tests? Go on, admit it. Even Jez has done it, hey? Wrong! Never do this! Even good people make this mistake, and no, don't slap. Don't ever do a bare sleep. The problem with a bare sleep is that you are always struggling with how long to sleep for. If you sleep for too long, your tests run really slowly. But if you don't sleep for long enough, all you've got to do is move on to a slower machine, or the machine is a bit more loaded that day than it was yesterday, and you'll get a test failure. Classic intermittent problem because you didn't sleep for long enough. And that tension between how long do I sleep for in order to get fast tests and reliable tests is pretty overwhelming. So just don't do this. You have two alternatives to fix this. And which one you want to use will depend a lot on the testing framework and the circumstances that you're in. One simple approach is a simple polling loop. And the trick here is you're kind of doing two sleeps, in a way. You've got the sleep inside the polling interval, and then you've got your timeout length that's part of it as well. And the nice thing is, you can keep your polling interval nice and short, and that way your test will never take longer to run until you actually detect what it is you're looking for. And your timeouts can be left nice and long. It does mean that if you get a slow response, your test will run slowly, but then it's inevitably going to run slowly. And if you set the timeout too low, then yes, you can get that kind of asynchronous problem, but that's less of an issue because you can afford to keep a fairly long timeout. And that polling loop is much, much better than a bare sleep for that reason. You've got two times to play with. And usually, as well, that timeouts should be set as some kind of easily changeable global constant, or somewhat global constant, so that you can easily increase the timeouts depending on if you have to move to a new machine and you're beginning to get problems. The other tactic for asynchrony is a callback. And basically the idea with a callback is that you carry out some function to go at the long-running function, and then you say, once that long-running function is finished, call this callback method, and the callback method itself contains the appropriate verifications as part of your test. Now, this will, of course, depend upon your testing framework. The testing framework typically needs some way to collect callbacks and to make sure they all get tested and that none of them have left hanging and things of that kind. But this is quite nice because it'll never take longer to run than you need to, but at the same time, you've got the defense against things taking longer when they do take longer. There's basically two strategies you have. What is the right one to use will depend upon the testing framework you're looking at, and sometimes based on the language. Some languages are easier to do callbacks, some not. I've seen this problem of asynchronous behavior a great deal in terms of web applications these days because of asynchronous JavaScript operations. And again, whether you use one or the other will depend on the testing framework you use for your JavaScript as to which it makes it easier. But whatever you do, don't use a bare sleep. And if you do use a bare sleep, replace it as soon as you can, because it's just asking to go non-deterministic on you. It's only a matter of time, in both ways, I guess. Okay, third cause. Interaction with remote services. So the interaction with remote services problem, typically you've got some app that you're working on, and then there's some remote system that you need to rely on in order to do something with your tests. Maybe it's a pricing engine, or a billing system, or a customer credit check, or whatever it is you're having to deal with. Most of us have to deal with remote systems some way or another. But the thing is that there are many things that can go wrong when you're dealing with a remote system that are nothing to do with your application code itself. You may have problems in the connection. Network may go down, or the network may become incredibly slow, or something of that kind. The remote service itself may have limited availability. It might go down, and then that would bring the tests down. You might find that you're relying on certain data to be present, and they're not very good at the remote end of keeping that data together. Sometimes they may give you test instances of a remote service to look at. Sometimes they may want you to call the live remote service. And either way, you have no control really about what data is available to you to make your tests. So as a result, there's all sorts of levels of instability, in all sorts of ways in which your tests can fail, not because of a problem with your code, but with a problem with the connection to that remote service. So the general solution to dealing with remote services, which also solves another problem that remote service calls are often very slow, is to use some kind of test double, a fake or a stub, for that remote service. That way, you control what data it's going to respond to, you control any changes that it makes, and also you make sure that you can have a fast connection and all the rest of it. So your tests will run faster, and they're less likely to suffer any problems due to non-determinism. But of course, a lot of people blanch a bit at this. They're saying, well, you're not testing the real remote service. Something could change there, and your test double hasn't changed. And it's basically a consistency question between the two. How do we know your double is really a good double of what that remote service does? And the way you fix that is with a different style of test. A test that I refer to as an integration contract test. And what the integration contract test does is pretty straightforward. It basically makes the same call to the remote service and to your test double and verifies that it gets back the same answer. And this way, you can ensure that your test double and the remote service are in sync. Now, integration contract tests don't have to be run as part of your main pipeline because they're going to fail not because of what you do, but because of what the remote service does. So the question you have is, how often is it likely that the remote service is going to have a problem that is going to come out that you need to check the consistency? And that will depend on what's going on that remote service side. If they only deploy changes once every blue moon, in theory, you only have to run your integration contract tests once every blue moon. In reality, most teams are probably going to run these at least once a day or so just to make sure everything's okay. But it's not part of your pipeline. It won't fail your build if the remote integration contract tests go down. If an integration contract test goes down, it does mean you have to figure out what went wrong, and it often may trigger a conversation between you and the remote service team to find out what's been going on. But that's a different style of problem and should be reacted to differently than your main pipeline itself. So there's more causes. In the article online, I talk about problems to do with time, problems to do with resource leaks, but I don't have enough time to talk about that now. So that's enough on non-determinism tests. I do recommend, though, that you take this stuff seriously, whether you're a tester, developer, manager, whatever. Flaky tests, I hear time and time again, are a cause of people losing faith in the test no longer giving you the value that it takes to have them. And since a good regression suite is such a wonderful thing, you really have to work at making sure it stays good. And I've identified this as a common problem by my totally unscientific analysis of projects I've happened to bump into. But I do think it's a more common problem than we like to talk about. And it's eminently fixable. The combination of quarantines and the kinds of investigations I've talked about here are capable of fixing a hell of a lot of these kinds of problems. And it's not rocket science, you can do it. So that's my first talk. So now we move on to something a bit more, that was kind of very sort of down concrete, nitty-gritty details thing. Now we move to something a bit more kind of waffly and philosophical. Although I still think a very important topic. Why is it important and valuable to think about well-designed software? And really, it's triggered by things like this that I hear. Anybody heard this being touted around or people using this argument? A few hands, not that many hands being raised. Well, you're all a lot more lucky or disciplined than I think you are. Or maybe you're just lazy and it's early in the morning, who knows? So this is the notion that I think of tradable quality. That we think of that quality as something that we can trade off for things. And it leads to the question of, okay, why should we care about design? Why should we put the effort into design in order to counter this kind of argument? And one person who has quite a good argument for why we should do something about this is this guy. Anybody recognize him? A smattering of you, at least. This is Uncle Bob Martin. Now, he has an argument about why we should care about software design, which I would like to briefly summarize. Badly designed software is a sin! Global variables were created by Satan as a trap for developers. And every time you name a method badly, it will be branded into your flesh in the burning fires of hell. Fair summary of his point of view, do you think? Now that works for Bob, but it doesn't kind of work for me. I can't really pull that off. So as a result, I kind of look at it a slightly different point of view. What's happening here is that people are following a notion that they have usually with quality, which is that quality is something that we can trade off for other things. You make this decision every day in your life, right? You say to yourself, do I want to buy, the cheap car or the more expensive fancy car? I mean, I'd like to have the more expensive fancy car, but I can't really afford it. I'd rather put that money onto other things, so I'll buy the cheaper one. That's a decision we make all the time. We trade off quality for cost. And it's a natural part of how we think about the things that we buy every day. But this then raises the question, what do we mean by quality in terms of software? Well, in fact, there are several things in software that we can talk about in terms of quality. But there's a very important distinction between some of them and some of them. And that is, are they visible to our users and our customers? A nice user interface, rounded corners, pleasant gradients, things like that, you can appreciate that difference. You know, when you look at a website, you have the nice modern looks, and then you've got those old ones that look like they were written in the 90s. You can feel the quality difference there. So you can make a statement as a user or customer of, do I want the rounded corners or not? But when it comes to the internals of software, have I got well-factored code? Am I using global variables? That kind of stuff. The users can't see it at all. It's a distinction that I make between internal and external quality. Now, as a buyer of software, if I've got a quality that's going to cost me some more, but not actually be anything I can perceive, why would I want it? Linda offers me a piece of software, beautifully crafted, perfect internal design, does 5 really good functions. Jez offers me software that does the same 5 functions, but is a sprawling mass of spaghetti stinking to high heaven. Linda's software is $100, Jez's software is $80. Which do I pick? As a user, I'm going to pick Jez. It's cheaper software, it does the same thing. What do I care what the insides look like? When you think about quality in those terms, you can see why no one takes it seriously. So why do I take it seriously? Let's face it, my whole life, my professional raison d'etre is about promoting good internal design of software. Kind of feels like a bit of a hopeless errand at the moment. But I have a reason. And this reason is something I give the kind of ugly, but very Googleable name of a design stamina hypothesis. It basically looks like this. If we plot a pseudograph of cumulative functionality versus time, what we see with badly designed software is a curve that looks like this. Basically means that we can make progress rapidly early on, but then over time things slow down. They slow down, so we're not paying attention to refactoring, we're not keeping our code clean, we're not having those regular conversations about keeping the design good, we're just hacking stuff in, and over time everything gets slow and difficult to build. How many people have been on projects where they've had that kind of feeling? Yeah, pretty much everyone, that's usually the case. But there is an alternative, to put attention into design, to refactor regularly, to keep your code clean, to make it understandable. And the hypothesis is you can change the shape of that curve. Not just can you stop that slowing down effect, maybe you can even get a speeding up effect. where you have some new functionality, and you're able to put it together really quickly because you're able to grab this object and wire it together, stick a little thing there with that object, and you're done. How many people have been on software that have been like that? Well, a few of you. Less, but a few of you. And that's the essence of why this matters. Because we feel there is this difference between those two curves. I refer to it as design stamina, because what I'm saying is design gives us the stamina to keep building quickly. Yeah, I can buy Jez's software for $80 now, but in a year's time, Linda's come up with 5 new absolutely killer features to her software, and Jez has barely managed to crank out one. Who's the fool now? What's the better choice? The internal quality gives us that long-running stamina to keep developing new features and keep doing new stuff cheaply and quickly. And I call it a hypothesis because, we're in the software business. We don't have any proof of any of this. We have no way of measuring our output. And as a result, we can't prove this. But a lot of us believe this hypothesis to be true. How many people would put their hands up on that? Do you think that's true, that those curves exist? Yeah. Most people I talk to think that happens. And that's why we care about design. So let's run with this a little bit more. Let's take this hypothesis a bit further. Think about another pseudograph. I want to add a new feature. And I've got two systems, a clean system, Linda's system, and a typical system, Jez's system. I'm really picking on you today, aren't I? So what we see, of course, is the design stamina's hypothesis tells us there's a difference between the two. Effectively, this is a cost, an economic cost to poor design. And this is where I feel, this is my argument, basically, in its intrinsic sense. Many people in the software industry take this kind of, you should do design because it's good for you, because it's the right thing to do, etc., etc. But, especially in this place, in Las Vegas, I know one thing. Morality people can talk about, but money almost always trumps it. This is money. This is the economics of software design. No morality needed, just straightforward money. The problem, of course, is it's unmeasurable money and not properly accountable, so it's not as good as it could be, but it does provide the line of argument. And a good way to help communicate this to people is to think, well, what's happening here is that if we've got complexity in the software that we don't really need, that causes this extra effort to new features. And there's a relationship between the two, the quality of this code base and the effort to add new features. And pulling this all together is a lovely metaphor that Ward Cunningham came up with called technical debt. And what Ward said about this is that you can think of it in terms of thinking in terms of financial debt. But the unnecessary complexity in your code base is like the principal of a debt. And the extra cost that you have when you implement new features is the interest payments on that principal. Now, what I like about this metaphor is that it gives us a way to communicate to non-software people something about what's going on in the code base. It's very hard to talk to them about badly named variables and poor factoring and things of that kind. But this metaphor does seem to communicate something. And it also, in particular, leads us to a very important part of a decision about what to do about it. Because if you have got accidental complexity in your code base, what do you do? Well, it's like what you do when you've taken out a loan. You've got two choices. You can pay off the principal, or you can keep paying the interest. Or you can obviously do some combination of the two. But it's always a trade-off, a choice between what's going on. And when you're building new software, you can say, am I going to do the quick and dirty approach and increase my debt and therefore increase the interest payments I'm going to make in the future? Or am I going to try and pay down the principal a little bit and reduce those interest payments? And you can begin to get some connection with the economics. Again, it's not a perfect metaphor, but it does work rather well. And I see teams beginning to track this. It's quite common, I think, now for teams I've talked to actually add technical debt stories to their backlog and say, these are things that we know we need to do because we've got debt that we need to pay down. The tricky thing, though, is trying to give some way of conveying what the interest payments look like, because you need both halves of the picture to be able to make that trade-off. And that's something that I think that people are finding a lot harder. So that's a basic metaphor of technical debt. But I want to explore a little bit further and think about how we get into technical debt. Because actually technical debt comes in different forms. And this basically came from the seeds of this came in a kind of one of those little blog arguments you have. Actually, it was with Uncle Bob. And it came upon the nature of different kinds of technical debt. Often when people talk about technical debt, they talk about it as a conscious decision of saying, I've got a deadline coming up. I know I have to get the software, certain functionality out by that deadline. I'm prepared to trade off some of the quality, take on some debt in order to hit that deadline. And if you think about it, that's the way in which we actually normally use debt in life. We say, well, I need something, it's more valuable for me to get it earlier. It can often be a very sensible economic decision. I want to build a factory to build some new product. I have to take out a loan that will pay off over time, but because the products sell, it's a good economic decision. Everybody wins. But people also are using the technical debt metaphor to use stuff where people have just created a whole load of crap without really knowing what the hell they're doing. You go in, this happens to us a fair few times, some client calls us up and says, we're having trouble with software, we send in some thought workers and they open up the source code control system and they go, oh my God. These people didn't clearly know the first thing about software design. And the question was, is that case where people don't know about software design, is that actually technical debt? Because it's been taken out in that kind of way. And Uncle Bob's argument, at least initially, was that it wasn't. And it's certainly a different kind of thing to that conscious decision earlier on. But I still think the debt metaphor is handy because it helps us with that question of what do we do about it. Do we clean this code up? Or do we keep adding new features and paying the interest? That trade-off still exists, which is rather handy. But it also makes us think about what is different between those two cases. Well, one of those things that are different is the thoughtfulness that went into it. And if you're making a conscious decision about what I'm going to do and trying to hit a deadline, that's the example I'm giving is a kind of a prudent decision. And just getting into tons of debt is a reckless one. And if we think of it in financial terms, the parallels are obvious. I think we all know of people that have got themselves into reckless debt by not paying any attention to what it is they're borrowing. In fact, we can even perhaps think of some governments who have done the same. Another difference, though, is whether the debt is deliberate or inadvertent. In the first case, my scenario, the people knew they were taking on debt. They were deliberate about the fact that they were taking it on. While in the second case, they had no idea what they were doing. They had no idea that they were taking on so much debt. So I think there's an interesting pair of distinctions between those two examples. But of course, something even more important has just happened. The dream of every consultant, I've created a quadrant! You're supposed to cheer and clap with that, it kind of leads to the moment. I'm sure the people in the virtual world did, so, But the people here are a bit slow on the uptake, they haven't had enough coffee. Now, quadrants are, of course, a very important part of any consultant's armory. I'm told that Gartner has a special bonus program for how many quadrants you create a year. But the interesting thing about a quadrant is it makes us ask the question, what's in those other two boxes? The first one, which is very interesting, is what is reckless and deliberate debt? And the answer is it's very, very close to prudent and deliberate debt. It's both along the lines of saying we don't have time to do design here, we've got to go fast, so therefore let's skip the design bit. But this decision is often made without really understanding what's going on. Let's go back to our little curve here. We talk here about the difference between good design and no design or poor design. There's a very important point, which is where those two lines cross, or a point I call the design payoff line. If you sacrifice effort on design in order to go fast, for a time period that takes you above that design payoff line, you haven't actually benefited. You've actually deliberately taken on technical debt and ended up going slower anyway. The decision to trade off depth for speed only makes sense below that design payoff line. And of course, it only makes sense there if it kind of really balances off all the various other factors that we might think about. But it never makes any sense above that design payoff line. Of course, the question then is, how far away is that design payoff line? And of course, we can't measure this. But my gut feeling, which is generally echoed by people I talk to, is that it's somewhere in the order of weeks, not in the area of months. It's a lot shorter than most people tend to think it is. And that is an important point about the distinction between a prudent and reckless debt. You have to think about, am I at a point where I'm going to tip myself over the design payoff line? In which case, there's no point sacrificing design for speed, because I'll end up losing both. One last space in the quadrant, and a really weird one. Prudent, inadvertent debt. At this point, the financial metaphor kind of breaks down. People have suggested some prudent, inadvertent debts, but none of them have really worked for me. What the hell is that? This struck me when I was in London a year or more ago, and I was chatting to a solid lead developer at ThoughtWorks. One of the guys that we happily trust on a software project, very solid. He'd been on a project for a year, and I was popped in. I wanted to chat with him, find out how his project gone, gathering little tidbits of information, which is a lot of what I do. And he talked about the project. They'd worked on it for a year. They'd delivered to the customer. The customer was really happy. Things had gone kind of, generally sounded like they'd gone pretty well. Everybody was reasonably pleased with the whole thing. But he didn't seem terribly happy. And I said, well, what was up here? What's wrong? And he said, well, the design really wasn't very good. We didn't really deliver that great code. And I said, but Ben, you're one of our best developers. Well, how did this happen? And he said, well, when we started off, we made decisions that seemed good decisions. But now, looking back at it from a year on, I realized they weren't the right decisions. We should have done something slightly differently. Anybody else had that impression before? Pretty much everyone, yeah. So the point of prudent, inadvertent debt is that even the very best software teams in the world do this all the time. Because the nature of software is that you don't really know the best way to design a piece of software until you've been designing it for about a year. And then you begin to realize, oh, this is exactly how things should fit together. And at that point, you realize you've taken on a debt without even noticing it. Not because you've been stupid, but because you just didn't know, because we're always learning. And this is a very important form of debt, and it's actually the debt that Ward was most talking about when he first came up with this notion of technical debt. It means that even in the best systems with the best people and the best attention, you'll still build up some debt that you then have to decide how to deal with. That's a natural cause of even the best functioning teams. And it's also, of course, another reason why you've got to be extra wary about taking on any other forms of debt, because you've always got a certain amount that's inevitably going to be drawn out. So I found that quadrant a handy way of thinking about debt. If you want more, generally, if you want to find out more about anything I'm talking about, go to the top link up there, the Talk Notes link on the Blicky, because I have notes and links, and I have several Blicky articles in which I've talked about these ideas. And therein ends my second talk. So it's that time of life now where those of us who got involved in writing the Agile Manifesto are being constantly reminded about our age and gradually growing decrepitude by told it's our 10th anniversary. The Agile conference in a couple of months, we've all got to turn up and parade around in T-shirts saying, we are the genii who created the Agile Manifesto. Hopefully it won't say exactly that. But it's a natural thing to reflect a little bit on where we are in the Agile movement after 10 years. And I'm going to do something slightly different for this segment, because I'm not going to use slides. I haven't really come up with a good set of slides for this, so I will need slides at one point, but until then, We'll just kill the visuals. So the first thing I want to say about this is to think a little bit about where we actually were 10 years ago. And I think this is important because it's easy when talking about things like where is the Agile movement and what should we mean about talking about Agile software, it's easy to forget the history. And maybe it's because I'm a history buff, but I always think knowing how things got the way they are is a very important part of understanding why something is the way it is. History is very useful. It's true in code bases, in companies, in the way you do things organizationally, and in things like the Agile software movement. So back in 2000, what we saw was a world with a lot of chaotic, badly managed, uncontrollable software projects. I don't actually know if it's any worse than it is now. I think a bit, but it was definitely the case. And there was also, I think, a growing sense that there was a group of people who felt they had the answer to this. And the answer is big methodology, what we call plan-driven methodology, or what I often refer to as the engineering approach to software development. Get all those requirements pinned down, make sure you've got them straight. Only once you're really sure you understand all your requirements, go on to design and the whole waterfall stuff. Lots of documents, lots of process in order to go things. And that very much seemed the direction in which people said, this is how we should build software. But there were some of us who would use different approaches, a very different style approach, what we now call agile thinking. Rapid iterations, lots of collaboration, lots of approaches towards an evolutionary approach to requirements and design and architecture, everything that we now talk about as agile. And we had success with those techniques. And what we felt was there was a danger that the industry was going to go so running down this heavy methodology route that we would kind of get trampled and not allowed to do what we knew would work in many situations. I don't think most of us thought, certainly I didn't feel, that the agile approach was the right one to use in all situations. But what we felt is that it certainly was the right one to use in many situations. And we wanted to ensure that we could continue doing that. And these approaches were all kind of different kind of flavors. There was extreme programming, which was probably the most visible one at that point, 10 years ago. There was Scrum. There was feature-driven development, a whole bunch of things like that. And the origins of the get-together at Snowbird, where we got together for the Agile meeting, was actually a year earlier when Kent Beck organized a workshop to talk about extreme programming. It was near his home in Oregon, which is you kind of go into the middle of nowhere, and then you go further on into nowhere for a couple of hours, and then you get to where he is. And at that workshop, he brought together a bunch of people who were active in the extreme programming world, but he'd also brought together a few people who were kind of hovering on the outskirts of the extreme programming world. I think Prag Dave Thomas was there and Jim Highsmith was there. And one of the questions that we faced was, well, what really is extreme programming? Kent had described it as a very particular set of practices governed by a set of principles and values. And the whole worked pretty nicely as a way to sort of start off and to think about building software. But there were people who liked the values and to some extent the principles, but didn't like the particular practices. But those values were very powerful. So the question was, should extreme programming be an expression primarily about the values, or should it be something more concrete? And Kent felt he wanted it to be concrete because that way it gave a bit more concrete advice to people about what to do. But then, of course, that left the question. What was that commonality in values? And that kind of is what led to the Snowbird thing and why, as part of the Agile Manifesto, we focus so much on values, to try and say this is what we have in common in terms of the values of the way we think about software. But the actual concrete practices about how you do things, they can vary enormously. It's the values that kind of hold us together. And we didn't actually go into that meeting intending to write a manifesto. We were just kind of invited to get together and discuss our different approaches. And my hope was just that we'd get together and learn some ideas from each other. I mean, the various approaches had stolen ideas left and right from each other before. And I'm always happy to steal ideas, so that was what I was looking for. As I remember, it was Uncle Bob who said, we need a manifesto, a statement of what we believe in. And I was kind of thinking, well, okay, I'll go with it. And as it turned out, I think the manifesto had a really good beneficial effect. It really helped coalesce people around that kind of thinking. It's surprising to me, but it did work out really rather well. But in the end, it's worth remembering a point, that the people who turned up and wrote it just happened to be the people who were free on that week and turned up. There were actually quite a lot of people who were invited who didn't make it. We got a good set. I think that was, and we were fairly lucky about how that worked. And a very collaborative group as well, I must say. But as I look at the world 10 years on, and I talk to the people who were there in the early days, both the manifesto authors and the other people who were active in the Agile, what was now called the Agile community at that time, I actually get a sense of unhappiness. People say, well, you know, Agile isn't really not that interesting, or it's gone sour, or I want to be so over the Agile thing, and Agile doesn't matter anymore, and that kind of stuff. It's not a feeling of, yes, we've kind of made a big blazing direction in terms of the industry, a feeling of triumph at all. It's actually a kind of feeling of, blech, you know, that kind of feeling. That's what I actually detect most, which is kind of surprising in a way, considering how Agile, you know, there's conferences left, right, and centre that are talking about it and all the rest of it. Why are people so blech about it? Well, a large part of the reason that this is happening, well, I think there are two main reasons. The first thing is something that's kind of an inevitable consequence of success. And it's something that was very obvious in the days of object-oriented programming as well. People got interested in objects, and then other people started talking about it and passing on, and the ideas spread out. But the problem is, as the ideas spread out, Chinese whispers began to set in. Somebody started talking about, oh, this is what objects are, and you'd look at that and you'd say, that's not what I understand them to be. And the same here with Agile. People are talking about, oh, we have a Scrum team, and the Scrum Master assigns work to everybody on the team every day at the stand-up meeting. You go, no, I don't think that was what Ken was talking about. It's a process that because I love coining these Googleable phrases, I call this semantic diffusion. Over time, as things get passed out, the semantics, the meaning of what we're talking about, gets diffuse. And I think a lot of the feeling of bleh about Agile comes because we see that semantic diffusion happening. Now, I see semantic diffusion as an inevitable consequence of success. I mean, the alternative is we're all very conscious and active in Agile stuff, but there's not very many of us, and we don't get to do very much. The benefit is that we actually get more opportunities. When we were at ThoughtWorks, we're doing stuff with Agile in the early parts of the decade, we had to be very careful about what we were doing. I mean, clients would say, I remember in one case very vividly being told of a client who had said, well, we really like the way you've developed this software, and things have been happening really fast and really low defects, but we've heard rumors that you're doing this Agile stuff. We don't want any of that around. Now, clients come to us saying, oh, we want to transform our gazillion-member IT department and turn them Agile in 6 months. You can do that for us, can't you? And, yeah, that's pretty ugly as well, but at least we're no longer sort of having to do Agile under the covers. We can be much more open about it, and that's a good thing. But it is that consequence of success. And I see semantic diffusion as an inevitable part of success. Anything that's successful spreads faster than the semantics can follow it. It's kind of running quicker than the semantics can keep up. And our job, of people who believe we understand the semantics, is we've just got to keep plodding away. We've got to keep reminding people, what is Agile about? What are the core concepts? No, it's not about Scrum Masters assigning tasks. We have to keep saying that, and we have to have a lot of patience for it, because this is actually a very difficult time for any movement. You've got the initial enthusiasm has kind of blasted out really fast, we can't keep up, and it's a slog. But it's what's needed is it actually going to have the degree of traction and change that we want to achieve. And this is where it sort of floods into the second reason, I think, why people are unhappy, is because we are in the early days of a very long-running change. I think about the object-oriented revolution, as it were. Well, objects kind of started in the late 60s, were kind of coalesced and put together by the small talkers in the 70s, had a good definition of what object orientation really was with Smalltalk 80 in 1980, but it still took about 20 years or so before I would say objects were mainstream. You know, the major languages like Java and C++ and C# were object-oriented. So that's a 20, 30-year process to get objects into mainstream languages. And still today, now 40 years on, I'm constantly told by my colleagues that they go into clients and look at their object-oriented Java code and they say, there aren't any objects here, it's just procedures and naked data structures. You know, a few getters and setters, that's not objects. So the object revolution still hasn't actually become truly mainstream yet. 40 years. And Agile, well, for a start, it gives you some sense of how long it takes, but I think Agile thinking is actually going to take longer, because Agile thinking affects way more people. It alters the whole relationship and power structures around software development organizations. Testers suddenly have a completely different role in the software development process than they had before. Managers have a whole different role. Developers have to do things differently. It changes everybody. It's going to take much longer for the Agile movement to have an effect. And we're only 10 years in. You know, if the Agile Manifesto is the equivalent of Smalltalk 80, you know, we're basically objects circa 1990, but with a much longer horizon to go. I'm hoping that things will be well understood and mainstream by the time I die, but I realize it could take that long. And unfortunately, that's one of the things I think that makes people feeling depressed. They wanted the revolution to have finished by now. I'm sorry, it's going to take decades. We still get benefit along the way, but it's a long process. So that's why I think people are feeling a bit bleh. And of course, one of the consequences of people feeling bleh is they say, well, why should we care about Agile at all? And I do hear this quite often from people saying, I don't care about Agile anymore. It doesn't matter to me. But I have a bit of a question about point of view, and this is where I do need to go back to the slides. I can get them to appear. Oh, there we are. Buttons are doing something. So this is the front page of the Manifesto for Agile Software Development on the web page. Hopefully all of you have seen at some point. And I hope many of you have signed it. How many people here have signed the Manifesto? You know there's a little page you can sign it. There's been quite a lot of signatures over the years. I want to focus on the values. This is, of course, a very striking way of writing that somehow we came up with. I have no idea how we did, but it was really effective. The basic idea is we come up with 8 valuable, useful, good things in software development, but we arrange them in pairs so that one valuable, useful thing is more valuable than the other valuable, useful thing. It's very important that the things on the right are good, valuable things. It's just we prefer the ones over the left more. Now, when we did this, we actually had a very important guiding light to us, which was we were very conscious of this drive to the engineering methodologies. And part of the structure of this is that we could imagine you flipping all of those values around, and that would be the value system of the engineering methodologies. You know, they care about process and tools more than individuals, because they want individuals to be these plug-compatible people that they can just move around. In an engineering process mindset, that's what you want. The comprehensive documentation over working software is a little bit weird in some minds, but I remember hearing it. I remember people saying, you know, the important thing is to produce the design diagrams. That's where the intellectual work is. Once we've produced the design diagrams, we can just sling them out to a bunch of coders and they can just code it up, preferably in India where it's cheap. And that is definitely the attitude. You know, we have to have contracts decided and sorted out. We follow that contract. The whole basis of our conversation has to be, is it in the contract? A lot of organizations work that way. And of course, we absolutely have to follow a plan because our definition of success is, did it go according to plan? In an agile world, did it go according to a plan it's kind of interesting in a kind of weird way, but no one would define success as, yes, we were on time, on budget. I mean, that notion of on time, on budget, that says things went according to plan. For agile people, success is the customer more successful in what they do because of the software we've produced? You know, have we made the customers' lives better? That's the agile definition of success. And whether it followed the plan or not is kind of irrelevant, really. Which doesn't mean the planning isn't important, but it doesn't become a success measure. So when people say they don't care about agile, what does that mean? Well, what it means is that they don't care about which way round those values are. They'll be equally happy with all the values flipped or all the values as they are in the manifesto. And I personally believe that many of the people who tell me, oh, I don't care about agile anymore, they would not be equally happy working in a flipped or agile environment. They actually do care a great deal. They may be a bit sick or tired in the hype of the semantic diffusion and of big companies launching their agile practices and all the rest of it, but they do care about the values in which they work. And I think that's something important to remember. We care about this because of that value system. At least that's what I care about it, of course. So the next thing that I wanted to talk about a little bit is to talk a bit about where things are going in the future. Now, those who know me know that there's this kind of line that occurs when people come up and talk to me who don't know me. People will come up to me and they'll say, Martin, what are the big future trends in software development? And I have this line that I always say that I don't know anything about future trends. I'm not interested in the future. I'm interested in the past. I'm a patterns guy. I'm rummaging through software projects in the past and finding, well, this was a good idea. We should do this more often. That's my life. I'm an intellectual dumpster diver, looking for interesting stuff that people kind of discarded that actually is really kind of interesting. So I'm not very good on this future-looking stuff. I leave it to these futurists that get up on stage and tell you what the future is going to look like, and hoping fervently, of course, that nobody will look at what they told you 10 years in the future to find out how wrong they usually were. But there are two things that I wouldn't say are futures, but are definitely current things that I think are really interesting. And they're both things at the sort of what would be the extreme edges of the traditional software lifecycle thinking, which of course kind of goes away in the agile world, but it's a good way of thinking about it. The first of these is user interface, user experience work. Now, when we actually did the manifesto, there was various discussions. I remember particularly with Larry Constantine, because he was very into user experience stuff at the time. And he was saying, well, you're not talking enough about user experience stuff. And we said, well, you know, we've got kind of a broad reach as it is. We've got some broad ideas, but that's one of those things that we expect will develop. And it's actually developed a bit slowly for my taste. When I do my travels around ThoughtWorks projects, a common and rather sad theme that I hear is people say, oh, well, we engaged this design agency, and they gave us this beautiful book full of photoshopped images of what the website should look like and how it should interact and everything. Build that, please. And we look at it and we go, well, you know, they're asking for this. That's quite expensive, and we could do that, which is just as good, but a hell of a lot cheaper. And they say, oh, but the thing says this. That's what the design agency said. Okay. And furthermore, we can't launch a minimal viable product and then build and change and learn from the experience because we've got to do what the design agency says. But that's slowly changing. More and more people are beginning to get into the notion of saying, how can we evolve the user experience at the same time as we're building the software? And there's a lot of the more serious websites do this kind of stuff with things like A/B testing and canary releasing and stuff like that, where they will actually, hey, here's a new feature, let's put it out to a subset of our audience and see if they like it. We're actually getting to this lovely situation, I particularly love this, where people are figuring out the requirements of the software by watching what people do with the existing software and thinking, that might be an interesting idea. That's the total antithesis of traditional requirements thinking, right? You only know your requirements once you've built the software, and then watch what people do with it. And I think this notion of how do we combine agile thinking and user experience design so that it's a constant ongoing process, that's something that we're going to see more and more of. We've done a bit of that. It's still a minority, I would say, of our projects at ThoughtWorks, but it's definitely the way we want to see things doing more and more in the future. And I think we're seeing a shift in the user experience community. A while ago, it was definitely the view, it seemed to be that, oh, you have to figure out the whole user experience before you begin, because you have to. And now it's much more a sense of, oh, maybe we can change our user experience and evolve it as we're building the software. That notion that it can be much more combined seems to be gaining a lot more credence. And I think that's going to be an encouraging change over the next few years. That will increase. The other one is at the other end. One of the big struggles that we've seen is that we can build software very effectively within the software development team, get it all integrated, get it all running and tested and all the rest of it, but then have difficulties getting the whole thing to production, running, making money, all the rest of it. Some people refer to this as the last mile of software development. And the problem is it's kind of beset with all sorts of difficulties. People have not treated it seriously. There are organizational differences between development teams, testing teams, and operations teams. There's a real lack of knowledge about how to kind of make that software delivery process go smoothly. A lack of tools and automation. Too many heroic 2 a.m. in the morning fiddling around with server controls and things. Or the other opposite, which is people given these paper scripts that they have to go through to figure out how to do a delivery. All that kind of stuff going on. But we're seeing a big shift in that, and the heart of this is a technique we call continuous delivery. And this is where I do my book plug. I'm not going to plug my own book, Domain-Specific Languages, although it is, of course, wonderful, and you should all buy a copy and read it and all the rest of it. I would certainly love it if you do. But actually, before you buy my book, buy the Continuous Delivery book, which you'll find out in the bookstores by my colleague, Jez Humble. Some of you saw our tutorial early on. I really do think this is a hugely important thing. It's what says, I mean, we look at clients that we've been into where they would barely get a few bug fixes out every 6 months to a situation where they were rolling new features out 2 weeks, and instead of spending the whole weekend to do things in the middle of the night, they were doing it Friday at 5s, hitting the command to say deploy the software to production, and at 5:30 going down the pub. And that to me is the most important thing, of course, because you don't want anything to stop you from going down the pub at 5:30 on a Friday night. So those are the two things that I think are the really interesting next steps. But one last thing I want to leave you with a little bit. In recent years, another thing that's happened is that we've seen a bit of an argument appear over the last year or so between what I might call the software craftsmanship movement and the Agile, and particularly the Scrum communities. It's a bit of a backlash, really, to the fact that one of the things that's happened with all the semantic diffusion is a lot of attention is paid to project management stuff and not programming stuff. Now, I think this is part of the working out and fiddling through of software development. And I like the fact that the software craftsmanship community is putting good attention onto internal quality of design. I've already told you why I think that stuff's important. But it also reminded me, really, of something that I hadn't really fully appreciated before. One of the things I really like about extreme programming, about the way Kent originally described his view of agile software development, was the fact that it unified the technical practices that you need to get software out with the more human interaction stuff about how do we manage that software development process and how do we communicate with the customer of software. In fact, at Snowbird, Kent was asked to sort of summarize extreme programming and say what it was about at its core, and he didn't talk about test-driven development or continuous integration or any of that stuff. He said, I want to cure the division between customers and builders of software so that they collaborate more closely together. That, for him, is the essence of what software development improvement is about. And it reminds us, as anyone involved in the software development process, that our job is to provide stuff that is valuable and useful and makes the customers and users more successful with their software. And we should always concentrate on that and always keep that at the front of our minds. It's good to get better at TDD, it's good to do NoSQL databases, it's good to learn how to do requirements in a nice agile way and all the rest of it, but at the heart, always guiding is how do we make the customers and users of our software more effective? And how does our software get towards that purpose? And then in thinking about that, I decided to take another step back. It's very easy, as software developers, to get very focused on, doing what we do and making sure we do our work better. But we also have a broader responsibility and a growing responsibility to say, is what we're doing not just making life better for our customers and our users, but is it making the world a better place? Well, one of the things that I see a lot in software development teams is they kind of say, well, we're order takers. You tell us what to build, we'll build it. But I think we have to show a greater responsibility in what we do and say, are we really building something that is better? One of the frustrations of many people, including myself, about the rise of the financial industry in the last 20 or so years is a hell of a lot of very bright brains are exerting all of that intellectual firepower on how to screw over more people when it comes to money. And how do I make a bit more money than that guy over there? And how do I, play in that casino? Very appropriate considering our setting. And that's a terrible waste for me. It's a waste of intellectual energy that should say, we can do things better. And this doesn't necessarily mean you sort of go off to Africa and build houses or something. In fact, I would argue it very much doesn't mean that, because that's not really using your intellectual capabilities. But I think it does mean that all of us must stop every so often and think about, I'm using my skills for my employer or for whoever's paying me, and that's good, but is that contributing to making the world a better place? Sometimes those things can be very simple. Sometimes some things can be a bit more broad. But I think it's something we have to think about a lot more as software developers. Our industry is growing increasingly influential. The world is becoming much more connected through websites. We're seeing software everywhere we look. And we have to start stepping up and saying we want to take responsibility for what that software does and what impact that software has on society. And we have to think about how we exert that responsibility and what we do with it. I don't have any answers, and I don't want to make any suggestions, even with my carping about financial industry, but I do think it's something that you should all individually ask about for yourself. When you're traveling home, on your flight home, think about, how does what you're doing have an effect? How can you make it have a better effect? And on that mushy note, I will finish the talk. Thank you.